Okay, so we've done quite a bit of work with vectors already. Let's just do a little bit more before we get into the more advanced topics. Let's say we have a Cartesian grid and we have our x and y axes like this, and we have a point here. I'll call this point A, and we have a point over here. I'll call this point B. And each of these points, we have a set of coordinates. So at A, we have the values 1 for x and 5 for y. For B, I have the x value of 6 and a y value of 7. Well, between these 2 points, I can connect them together, make a little line segment, and I can say that this is actually a vector. In fact, I would call it the vector AB. So far when we're naming vectors, you've seen me call them vector, V, vector A, vector B, things like that. But you can also name a vector like this, and when you do, it indicates that it's going between the 2 points A and B. So that's perfectly okay, we can do that. Now, what we would say next is, how do we find the component form of this vector? Well, again, if point A is 1, 5, and point B is 6, 7, then all we have to do to figure out the vector AB's component form is subtract the x values and y values. All you have to say is 6 minus 1 and 7 minus 5. And if you do so, you'll get the answer 5, 2. Now, when you think about it, this makes sense because when you're looking at the graph over here, if you were to count how far this distance is, the x direction of this triangle, if you were to make this into a right angle triangle, in this x direction, you have a length of 5, right? If you go from 1 to 6, that's a length of 5. If you look at this height here, you go from 5 up to 7, right? This here is a gap of 2, right? It's kind of like when we're doing slope. You find the rise and the run. You can find the rise and run either by subtracting the x and y values like we did over here, or you can look at it graphically and just count, right, what those differences are. And so these values actually represent the rise and run. If you were trying to figure out the slope of this vector, we would say the slope is equal to 2 over 5, because that's the rise over run. Those are the same numbers we use here for x and y in our component form. So it's very easy to figure out the component form of a vector. If you're given 2 points, just subtract the x values and subtract the y values. Now, your point B here, those are the numbers that we're putting first, and the point A, those are the numbers that we are subtracting from point B. So if it's vector AB, we do B minus A. If I had the opposite, if I have vector BA, and I'll use a different color for this. Vector BA is the opposite. It is A minus B. It is 1 minus 6 and 5 minus 7. Now, why is it the opposite? Because vector BA is the vector that goes from point B to point A. It goes in this direction, the opposite direction of vector AB. So it absolutely matters the order that you're stating those points, right? Because in this case, we would have -5 and -2. You notice it's the exact same numbers as here, except they're both negative because we're going in the opposite direction. Remember, with vectors, the direction matters. It's not just a line segment, right? It's not just a magnitude, it's a magnitude with a direction. So if it's vector BA, we're going from B to A. If it's vector AB, then we're going from A to B. So you always do that second point minus the first point. That second point minus the first point in order to get these numbers. To verify that your answer is correct, you can look at the picture and confirm. Okay, am I going to the right by 5 and up 2 as I go from where it starts to where it ends? For that first vector AB, yeah. For the second vector, the red one, BA, you're going down 2 and to the left 5. That's what these negatives indicate, your directions. So hopefully that makes some sense.